Welcome to Deep Dive. We break down big ideas sent in by our listeners and do it in about 5 minutes. Got a topic, article, or book you've been meaning to understand but never had the time? Send it our way. We'll do the heavy lifting and give you the essentials fast.
Today we're tackling a big one, Stephen Hawking's A Brief History of Time.
A landmark book for sure. Changed a lot of things.
Exactly. Our mission, really, is to pull out the key ideas, give you a kind of shortcut to understanding, well, the universe.
From the start of time itself to black holes, it's all in there.
Okay, let's jump in. Hawking starts right at the beginning, doesn't he? The Big Bang.
He does, but maybe not in the way most people picture it.
Right, not just an explosion in space, but the origin of space and time.
Precisely. He forces us to ask if before the Big Bang even makes sense.
And he also gets into those huge questions. Is the universe finite? Infinite?
Will it expand forever or maybe collapse back in?
What does that really mean for us, though? Why are those questions so fundamental?
Well, understanding that beginning, that potential end, it frames everything. It tells us about our cosmic home, our context. Is time infinite? Did it have a beginning? Hawking suggested time itself might have started then, making before meaningless. Like asking what's north of the North Pole. It redefines our whole place in the cosmos.
Right, yeah, that's a huge shift in thinking. Okay, so from the universe's origin, he then zooms in, right, to the link between space and time.
Yes, building on Einstein.
Einstein's theories, they completely changed how we saw gravity. It wasn't just a force pulling things.
Not at all. He gave us space-time, this unified fabric.
Often described as this flexible sheet, almost.
Sort of, but it's more that mass and energy warp this space-time. And that warping, that curvature, is what we experience as gravity.
So planets orbit the sun not because they're pulled?
But because the sun creates this dip in space-time, and the planets are essentially rolling along the curve.
Wow. Okay. That really did reshape physics.
Fundamentally, our whole view of reality shifted.
And speaking of shifting our view, black holes. That's core Hawking territory.
Absolutely. One of his biggest contributions.
We used to think of them as just cosmic vacuum cleaners, right? Nothing escapes.
Right.
Ever.
That was the picture. Inescapable gravitational monsters.
But Hawking,
Yeah.
he said they leak. That they can, evaporate.
Exactly. It sounds completely counterintuitive. How can something leak from a black hole?
How did you figure that out?
It involves quantum mechanics. Right at the edge, the event horizon, particle pairs pop into existence. It happens everywhere, all the time.
Okay.
But near a black hole, sometimes one particle falls in and the other escapes.
And the escaping one carries energy away.
Precisely. It's like the black hole is very, very slowly radiating energy away. We call it Hawking radiation.
So it could eventually disappear.
In theory, over unimaginable timescales, yes, it could evaporate. A huge theoretical breakthrough.
Bridging quantum mechanics and general relativity, you mentioned.
A really profound link between the physics of the very large and the very small.
Okay, let's talk about time itself then. Hawking makes this distinction, real time and imaginary time.
Real time is just, well, time as we experience it. Moving forward. Clock's ticking.
And imaginary time, what's that? Sounds like science fiction.
It's more of a mathematical tool, actually, a concept used in quantum mechanics and cosmology. Think of it as rotating the time axis in calculation.
Why do that?
It can help smooth out some problematic points in theories, like the singularity at the Big Bang. It makes the maths work more elegantly sometimes, avoids infinities.
Interesting. And the area of time, why does time only seem to go one way?
That's a deep puzzle. Why do we remember the past but not the future? It's often linked to entropy, the idea that things tend to get more disordered over time. Your desk gets messy, right? The universe seems to work like that too on a cosmic scale. That increase in disorder seems to define time's direction.
That's fascinating. Okay, so linking everything together, that's the big dream, right?
The ultimate goal for many physicists.
Hawking really highlights this major clash in physics. Quantum mechanics for the tiny stuff. General relativity for the huge stuff.
And they don't play nicely together in extreme situations like inside black holes or at the Big Bang. They give different answers.
There are two different instruction manuals for the universe.
Exactly. One for the atoms, one for the stars and galaxies. We need the one manual.
The theory of everything.
That's the dream. A single framework that explains all forces, all particles, everything.
Why is finding it so crucial? What would it actually tell us?
It would potentially explain the fundamental laws governing reality at its deepest level, why the universe is the way it is.
And just reporting impartially on his book here, Hawking did touch on the philosophical side too, didn't he?
He did. He explored whether if physics can explain the universe's origin and evolution.
If a creator is still necessary, he certainly posed that question.
Based on the potential completeness of physical law.
So looking back at this deep dive, we've gone from the Big Bang through space-time, black holes evaporating, different kinds of time.
The arrow of time.
And this quest for a unified theory. It's an amazing overview Hawking gave us.
A truly accessible entry point into some incredibly complex ideas.
It really is a shortcut to getting your head around modern cosmology.
Absolutely. But it leaves you thinking, too.
Like what?
Well, if we ever did find that theory of everything, suppose it really could explain it all.
Okay.
What new questions would that answer unlock? What would we ask next about existence itself?
That's a great point. The end of one search is probably the beginning of another.
Always.
Well, we hope this deep dive has maybe sparked some curiosity for you to keep exploring these huge ideas.
There's always more to discover.